Picture this. It's 2:17 a.m. on a Tuesday night in Copenhagen, 1927, and the greatest minds in physics are locked in heated debate at the Solvay conference. Einstein's voice echoes through the hallway as he argues with Niels Bohr about the very nature of reality itself. God does not play dice with the universe, Einstein declares, unaware that his words would spark a century-long journey into the most mind-bending discoveries in human history. Meanwhile, across the Atlantic Ocean, a young man named Neville Goddard stands before a mirror in his New York apartment, teaching himself to see beyond what appears to be solid, unchangeable reality. He doesn't know it yet, but he's about to articulate principles that would eerily mirror the quantum revolution unfolding in European laboratories. The story begins with a question so simple it almost seems childish. If no one is looking at the moon, does it still exist? This innocent inquiry would shatter our understanding of existence itself, launching us into a realm where consciousness and physical reality dance together in ways that would make even the boldest science fiction writers blush. The quantum world, as we've come to understand it, operates on rules so bizarre that physicists themselves admit they don't truly understand them. They simply know they work with mathematical precision that borders on the supernatural. In the 1920s, as quantum mechanics was being born, something extraordinary was discovered in laboratories around the world. Scientists found that by the very act of watching, the observer affects the observed reality. The famous double-slit experiment became the gateway to this revelation. When electrons were fired through two parallel slits, they behaved like waves, creating an interference pattern. But the moment a detector was placed to observe which slit each electron passed through, something impossible happened. The electrons suddenly began behaving like particles, and the wave pattern disappeared entirely. It was as if the universe itself was responding to conscious observation. Dr. Niels Bohr, the father of quantum mechanics, would later describe this phenomenon with words that sent shivers down the spines of materialist scientists. How does possibility become reality? This question, which he posed as the wave function collapse problem, sits at the very heart of quantum theory. The mathematics described probability amplitudes evolving through time, but offered no mechanism for how these ghostly possibilities crystallized into the concrete reality we experience. Meanwhile, in the same decade, Neville Goddard was conducting his own experiments with reality. Standing in front of audiences in New York City, he would make claims that seemed to echo from the quantum laboratories themselves. "Assume the feeling of your wish fulfilled," he would tell his listeners. "And your assumption, though false if persisted in, will harden into fact." But Neville wasn't talking about positive thinking or wishful dreaming. He was describing something far more radical, a fundamental law that connected human consciousness directly to the fabric of reality itself. The parallel becomes even more striking when we examine what Neville called the law of assumption. According to his teachings, consciousness is not produced by the brain. Consciousness shapes physical reality. This wasn't metaphorical language for Neville. He meant it literally. He taught that the act of assuming a desired state as already real would cause reality to reorganize itself to match that assumption. The mechanism, he claimed, worked through what he termed the bridge of incidence, a series of seemingly natural events that would unfold to bring the assumed state into manifestation. Fast forward to the 21st century and something remarkable has happened in quantum physics laboratories. The observer effect, once dismissed as a mere measurement problem, has been demonstrated with increasing precision. The process of observing a particle changes the way the particle behaves. And this isn't just a quirk of experimental apparatus. It appears to be a fundamental feature of reality itself. The implications are staggering. Consciousness seems to play an active role in determining what becomes real. But the connection runs deeper than mere observation. In quantum field theory, particles don't exist in definite states until they're measured. Instead, they exist as probability clouds, mathematical descriptions of all possible states simultaneously. It's only when conscious observation occurs that this cloud of possibilities collapses into a single definite reality. According to the Copenhagen interpretation of quantum mechanics, the collapse of the wave function takes place when a conscious observer is involved. Roger Penrose, the Nobel Prize-winning physicist, took this idea even further. Instead of consciousness causing the collapse, Penrose suggested that wave functions naturally collapse, and that this collapse is actually what creates consciousness. Whether consciousness creates reality or reality creates consciousness becomes a chicken and egg question that leads us into philosophical territory that would have thrilled Neville Goddard. The mathematical formulation of quantum mechanics reveals something that sounds eerily similar to Neville's teachings about assumption. In quantum superposition, a particle exists in all possible states simultaneously until measurement forces it to choose one state. The particle doesn't randomly select a state. The measurement itself, influenced by the observer's setup and intention, determines which possibility becomes real. This bears an uncanny resemblance to Neville's claim that conscious assumption determines which possibility from the infinite field of potential experiences becomes manifested reality. Consider the delayed choice quantum eraser experiment conducted in laboratories around the world in the early 2000s. In this mind-bending setup, physicists demonstrated that the decision of whether to measure which path information could be made after photons had already passed through the slits, yet this future decision still determined whether the photons behaved as waves or particles in the past. The experiment suggests that conscious choice can influence events retroactively, a finding that would align perfectly with Neville's teaching that assuming a desired state as already real can cause the past to reorganize itself to support that assumption. The quantum Zeno effect provides another fascinating parallel. Named after the ancient Greek philosopher Zeno, this quantum phenomenon demonstrates that frequent observation can actually freeze the evolution of a quantum system. By repeatedly measuring a radioactive atom, scientists can prevent it from decaying, essentially holding it in a specific state through the power of observation alone. This echoes Neville's instruction to persist in your assumption until it hardens into fact. In the field of quantum entanglement, particles become connected in ways that transcend space and time. When two particles become entangled, measuring one instantly affects the other, regardless of the distance separating them. Einstein called this spooky action at a distance, but experiments have repeatedly confirmed its reality. This non-local connection suggests that consciousness might operate on similar principles, that the act of assumption in one location can influence reality across space and time. The many worlds interpretation of quantum mechanics, proposed by Hugh Everett III in 1957, offers perhaps the most radical parallel to Neville's teachings. According to this theory, all possible outcomes of quantum measurements actually occur, but in separate, parallel universes. Every quantum event splits reality into multiple branches, each containing a different outcome. If this interpretation is correct, then all things already are, and the whole vast creation is already finished, exactly as Neville taught. The question becomes not whether something is possible, but which possibility we choose to experience through our conscious assumption. Modern neuroscience has added another layer to this mystery. Studies using fMRI and other brain imaging technologies have shown that the brain cannot distinguish between a vividly imagined experience and a real one. The same neural networks fire when you imagine biting into a lemon as when you actually bite into one. This suggests that your assumptions literally rewire your brain and influence quantum fields to create your experience. The boundary between imagined and real dissolves at the neurological level, supporting Neville's claim that assumption is the key to manifestation. The holographic principle in physics proposes that all the information contained in a three-dimensional space can be encoded on a two-dimensional surface, like a hologram. Applied to cosmology, this means that our entire universe might be a projection from information encoded on a distant boundary. If reality is indeed holographic, then consciousness might serve as the projector, determining which aspects of the infinite information field become our experienced reality through the act of assumption. Quantum coherence studies have revealed that biological systems, including the human brain, maintain quantum effects at body temperature, something scientists previously thought impossible. Microtubules in neurons appear to support quantum processes that might be the physical basis for consciousness itself. This biological quantum coherence could provide the mechanism through which conscious assumption influences the quantum field, translating mental states into physical reality. The observer effect extends beyond individual particles to entire systems. In quantum biology, researchers have discovered that photosynthesis in plants relies on quantum superposition to achieve near-perfect efficiency in energy transfer. The plants seem to explore all possible pathways simultaneously, then collapse into the most efficient route. This biological quantum computing suggests that life itself operates on quantum principles that mirror Neville's description of how assumption navigates infinite possibilities to manifest desired outcomes. Physicists have also discovered that information appears to be more fundamental than matter or energy. John Wheeler's famous phrase, "it from bit," suggests that physical reality emerges from information. If consciousness is the universe's way of processing information about itself, then the act of assumption becomes a form of cosmic programming, instructing reality about which possibilities to manifest from the infinite information field. The measurement problem in quantum mechanics remains unsolved after nearly a century of investigation. Multiple interpretations compete to explain how and why wave function collapse occurs, but they all acknowledge that consciousness plays a crucial role in determining reality. Some interpretations, like the consciousness-induced collapse theory, directly state that conscious observation is what transforms possibility into actuality. a principle that would have felt perfectly natural to Neville Goddard. Recent experiments in quantum computing have demonstrated that quantum systems can solve certain problems exponentially faster than classical computers by exploring all possible solutions simultaneously through superposition. The quantum computer assumes all possible answers exist simultaneously, then collapses into the correct solution through measurement. This technological application of quantum principles mirrors Neville's teaching about assuming the wish fulfilled, entering a state where all possibilities coexist until conscious selection determines which becomes real. The quantum eraser experiments have shown that the act of gaining information, not just measurement itself, affects quantum behavior. Even when information about which path a photon took is recorded but never consciously observed, the quantum interference pattern disappears. However, if the path information is erased before observation, the interference pattern returns. This suggests that it's not mechanical measurement, but information available to consciousness that determines quantum outcomes. In the field of consciousness studies, researchers have found correlations between meditative states and quantum-like effects in brain activity. Advanced meditators show increased gamma-wave coherence and long-range neural synchronization that resembles quantum entanglement patterns. These findings suggest that trained consciousness might indeed access quantum-level influence over reality, providing a potential scientific foundation for Neville's claims about the power of assumption. The bootstrap paradox in physics describes situations where information or objects exist in causal loops with no discernible origin. Effect becomes cause becomes effect in an endless cycle. This paradox appears in quantum mechanics when observation creates the very reality being observed. Similarly, Neville taught that assuming a desired state as already real creates the conditions necessary for that state to become real, forming a causal loop where assumption generates its own fulfillment. Dark matter and dark energy comprise 95% of the universe, yet remain invisible and undetectable except through their gravitational effects. Some physicists speculate that consciousness might interact with these hidden aspects of reality in ways we don't yet understand. If consciousness can influence dark matter and dark energy through quantum processes, it would provide a mechanism for the kind of reality-shaping power that Neville described in his teachings. The anthropic principle in cosmology observes that the universe appears fine-tuned for the existence of conscious observers. The fundamental constants of physics fall within extremely narrow ranges that allow for stars, planets, and life to exist. Some interpretations suggest that consciousness somehow participates in determining these constants, that the universe evolves in response to the possibility of conscious observation. This cosmic scale observer effect echoes Neville's teaching that consciousness is the foundation of all creation. Quantum tunneling allows particles to pass through energy barriers that should be insurmountable according to classical physics. This phenomenon makes possible much of modern technology, from computer chips to MRI machines. At the quantum level, particles don't gradually overcome barriers. They simply appear on the other side as if the barrier never existed. This mirrors Neville's description of how assumption allows us to tunnel through apparent obstacles by accepting our desired reality as already accomplished. The information integration theory of consciousness proposes that consciousness corresponds to a system's ability to integrate information in ways that create unified experience from diverse inputs. If this theory is correct, then the act of assumption, integrating desire with the feeling of fulfillment, might represent a specific type of consciousness that creates reality through information integration at the quantum level. Bell's theorem and subsequent experiments have proven that quantum entanglement violates local realism, the idea that objects exist independently of observation and that influences cannot travel faster than light. This violation suggests that reality is fundamentally non-local and observation-dependent, providing scientific validation for mystical traditions that have long claimed consciousness transcends space and time in its ability to influence reality. The quantum Zeno effect has been extended to show that specific types of observation can not only freeze quantum evolution, but actually steer it in desired directions. Through carefully timed measurements, scientists can guide quantum systems along chosen paths, essentially programming quantum reality through conscious intervention. This quantum steering resembles Neville's description of how persistent assumption guides reality toward desired outcomes through the bridge of incidence. As we stand at the intersection of quantum physics and consciousness research, the parallels between scientific discovery and Neville Goddard's metaphysical teachings become impossible to ignore. The observer effect demonstrates that consciousness influences physical reality at the most fundamental level. Wave function collapse shows how infinite possibilities crystallize into definite experiences through the act of observation. Quantum entanglement reveals that consciousness operates beyond the limitations of space and time. These discoveries don't prove Neville's law of assumption in a direct, mechanical sense. Science rarely works that way. Instead, they reveal a universe where consciousness and reality are far more intimately connected than materialism ever allowed, creating space for possibilities that would have seemed impossible just decades ago. The greatest mystery isn't whether consciousness can influence reality. Quantum physics has already demonstrated that it does. The real question is how far this influence extends, and whether we can learn to harness it consciously and deliberately, just as Neville suggested we could through the simple but profound act of assumption. As we continue to probe the deepest mysteries of quantum mechanics, we may discover that the mystics and the physicists have been exploring the same fundamental truth from different directions. Consciousness doesn't just observe reality, it participates in creating it, one assumption at a time.